Okay.
Hi, I'm Colton. This is a game that I made, and essentially there's going to be blinking lights, and then if you're able to flip the switch when it's on, you can go to the next one, and it's a faster blinking light, and so on, until you get
Okay, so you get it?
until you get it. And the way it works is an astable timer, and I had to figure out a way to pause an astable timer, and so I used a bistable timer to do it. And so I have the output of the the astable timer and the switch as an AND gate, or two AND gates, one for the trigger and one for the reset. And the astable timer is inverted on one of the AND gates so that only one's low at a time.
Okay.
And then essentially to get the four different light or flickering speeds, I just used a resistor values for the astable timer. I have a 5.4K, a 3K, a 2.5K, and a 1K.
Okay.
And then in order to be able to get it only when it turns on, I used some logic or an AND gate with an inverter at the end of it. And the inputs for the AND gate for that is the output of the bistable timer, and the other input is the switch. So only when the switch is flipped will the AND gate turn on, which will allow you to go to the next one.
Okay, cool. Okay, so you have a lock to prevent from future levels, and and when you get it right,
Yeah, so you have to get it right for it to move on to the next one.
yeah.
And these switches aren't the best, so sometimes they...
Yeah,
they
I
won't
think I
work all
pulled
the
it
way.
out when I moved my hand away.
Yeah, I see.
Okay, cool. All right, so it seems like everything's working that you described. So what kind of issues did you come up with while designing and creating this?
Well, the first issue was to figure out something that blinks or mimics an AC wave, and it was either going to be an astable timer or a multi-vibrator. But if I went with the multi-vibrator, the power efficiency would be lower, so I chose the astable timer. And then I had to be able to pause it, and then the only way I could think of was using a bistable timer, because if you remove the inputs, then they there. Except I couldn't get it to work properly because it was working without inverting the astable timer on the trigger, and so they were the same exact input, and it would still work, and I don't know why, and once I figured out that I just had to invert it, that was easy. And then the only hard part was making it to where it would only the next one would only turn on when you get the first one.
Gotcha.
Which was the AND gate with an inverter, because one of these inputs are like flipped from the other one. Like one of them was going to be naturally high and the other one's naturally low, so I had to invert it.
Gotcha. Okay, cool. So we talked about issues you had with building and designing it. So let's say you're given more time and resources. Is there anything you would like to add to the circuit? Anything you would like to fix? Like anything like that?
The main thing I would add is a safety feature for whether it overheats that turns off all the timers, so that nothing works. And the easiest way to do that would either be a comparator, and then adds one input on all the AND gates, so that nothing will turn on unless the comparator is flipped. And then you could switch out all of the AND gates for CMOS logic or diode logic, but then it lowers the power efficiency, so it's pointless.
Gotcha.
So yeah.
Okay, cool. Is there anything else you want to like show off or add to this, or is this it?
No, that's about it.
Okay, cool. I'll stop the video then.